this question says find the fraction that is equal to the recurring decimal 0.636363 and so on and so forth, where 63 repeats indefinitely. Okay, so this is a recurring decimal, and you must find out what the fraction that represents it is. Now, we're dealing with arithmetic series and geometric series. So this must be one of them. So what we need to do is to see how we can break this recurring decimal up into different parts that keeps adding up, and then we identify what kind of series it is. Now, you see the 0.636363. You can write it as 0.63 plus 0.0063. Now these two will give you 0.6363, but you have some more 63s there. So you add 0.000063. When you add these, you will get 0.63. This will give you 0.63, 63, 63, because you can see that if you add them up, you have 3 plus 0 is 3, 6 plus 0 is 6, 3 plus 0 is 3, 6 plus 0 is 6, 3 plus 0 is 3, 6 plus 0 is 6, 0 point. Alright, so far you have 0.636363. But remember, the 63 repeats indefinitely. So you could keep adding. So you have 0.00000063. When you add these, you will get 0.63636363. And you could keep doing this. So here now, let us write out these parts of the series sideways, these terms. This is 0.63 plus 0.0063, right? That's this part, plus this part is 0. How many zeros do you have? 1, 2, 3, 4, 4 zeros. 1, 2, 3, 4, 4 zeros. 63 plus. Then at this part, how many zeros do you have? 1, 2, 3, 4, 5, 6. They have 0. 1, 2, 3, 4, 5, 6 zeros, and then 63 plus. Okay, and it goes on like that. So that's the series. Now, the issue here is if it is an arithmetic series, then you should be able to subtract one from the other, and the one from the one term from the term immediately below it, and get the same thing if you subtract a next term from the term immediately below it. Let's test it. What is 0.0063 minus 0.63? And we find out if it is equal to 0.1234 4 zeros, 63 minus 0.0063. What will these give us? So if we try that, we're going to have 0.0063 minus 0.63, and we get, oh, the other way around, we should subtract it. 0.63 minus 0.0063, and we get 0.6237. Okay, with the other one, if we say 0.0063 minus 0.12340063, we get a different number. So it is not an arithmetic progression. So let's see, it must be a geometric progression then. So if it is a geometric progression, then a term divided by the term immediately before it should be equal to another term divided by the term immediately before it. So let's try this. This one over this one. What is it? 0.0063 over 0.63 is equal to, well, if we say we can, if we suppose we multiply both top and bottom by 1, 2, 3, 4 by 10,000 and then cancel down, what do we get? The top will become 63, because we multiply it by 10,000, we move the point 4 places to the right. Let's do the same thing here. 1, 2, 3, 4. This would be 6300. Now 63 into 63 goes 1 time. 63 into 63, 100 goes down 100 times. Okay, so we get 100. Now let's try the other one. This one is 0.123463 over this one is 0.2063. Okay, let's see something here. 1, 2, 3, 4, 5, 6. You have to multiply by 1,000,000 to get 63 up top. Let's do the same thing here. 1, 2, 3, 4, 5, 6. We're going to have 63 and 2 zeros after. Okay, 63 cancels itself to get 163. Divided into 6300 goes 100. We get the same thing. So it is a geometric progression. Alright. So I could just leave this as homework, as rough work. So we can say that this is a geometric progression with common ratio equal 1 over 100. First term, what is the first term? Is 0.63. The first term, A, is equal to 0.63. Okay. Now, the thing is, what do we get when we add up all of these things? Remember, you have the sum to infinity. So the sum to infinity of a geometric progression is A over 1 minus R. Alright? A divided by 1 minus R. You have to remember that formula in case you don't get a formula sheet in your exam. Alright. So this is going to be A, which is 0.63 divided by 1 minus R, which is 1 over 100. Alright? Now, this is 0.63 divided by, let's work it out, a fraction, 1 minus 1 over 100. That would be the same as if we use common denominators. 1 is 100 over 100 minus 1 over 100. This is 0.63 over 1/100th. Now 100 hundredth minus 100 gives you 99 hundredth. So it's 99 over 100. Alright? Alright. Now, the sum to infinity is therefore 0.63 multiplied by You remember your fractions now. When you have a number over a fraction, it's the same as the number times the reciprocal of a fraction is 100 over 99. So 63 times 100, 0.63 times 100 gives us 63, and divided by 99 could cancel down. 3 divided into 63, 3 into 6 goes 2 times, 3 into 3 goes 1 time, so that's 21, divided by 3 into 3, 3 into 9, 3, 3 into 9, 3. You could cancel down further, you know. You could cancel down with 3 again. 3 into 21 is 7, because 3 7 is 21. 3 into 33 is 11, because 3 11 is 33. Alright, so I get 7 over 11. Let's test it. 7 over 11. Is 7 over 11 equal to 0 0.6363636363 and so on? Let's see. 7 over 11 equal 0.6363636363 and so on. Good, good. So we got that. Alright. Alright, earlier we tested it whether this was arithmetic or a geometric series. We didn't really have to do that. The fact is, well, if you are familiar with this type of question, you wouldn't have to do that. The fact is, anytime you get a recurring decimal to turn into a fraction, the series that you will get is a geometric series, not an arithmetic series, right? And you can see that once it says it repeats, it means there's a sum to infinity, right? And with an arithmetic progression or arithmetic series, the sum to infinity is infinitely large, whether positive or negative. Alright? So it wouldn't be an arithmetic progression, it would be a geometric progression. Right? Because as long as the common ratio is less than 1, right? It's between -1 and +1, then you can find the sum to infinity, because each term you add keeps getting smaller and smaller. So you can find the sum to infinity. Alright, so that will be it for now. See you in the next video.